Okay, this is a video tutorial that I'm preparing in the playlist that is titled Transitioning from ABAQUS CAE to 3D Experience. It is intended for people who are either new to 3D Experience or who are familiar with ABAQUS CAE and they would like to try the counterpart of ABAQUS CAE, which is actually the ABAQUS program buried inside of the 3D Experience at its native FEA solver. The particular release that I'm using is release 2022x of 3D Experience, and the way these tutorials work is that I look at YouTube and find specific problems that have been done in a step-by-step way using the ABAQUS program, and then replicate the steps, counterpart of those in the 3D experience, so that people will get a feeling on how to how the icons interface and the platform changes when you go from ABAQUS to 3D experience. And it's also intended for people who are obviously new. So this particular problem that I'm going to be solving is in the software is already done by this YouTuber and using the ABAQUS program, and it's titled Bellow Modeling Tutorial. Now, a bellow is a gadget that allows you to pump basically high-speed air into a nozzle. This definition is taken from Wikipedia, and the reason that we are doing this thing because that portion of it, that portion of the bellow, actually looks like so. So the mesh that this person is using, this YouTuber is using, is shown here, and he uses 2 mm size mesh. It's a surface. This is a surface, and we're using shell elements. However, I chose 4 mm because it run a lot faster on my machine, which is not a very sophisticated laptop. The thickness of this shell is going to be 1.5 mm, and we're going to do it only in the elastic range. Young's modulus is 100,000 MPa, and the Poisson ratio 0.38. This is typical of polyethylene properties. He gets some results which are here. The intention is not to match these results, but to see how steps are replicated in 3D experience. Now, the cross section of this bellow is given by these points, and I'm going to input them one by one in the sketcher of 3D experience. Now, the alternative would have been to put these coordinates in an Excel file and read it into that, but I'm not going to do it here. Okay. Now, nonlinear geometric effect is going to be on, and the initial increment proposed by this fellow is 0.01, and we're going to use the same value. There is a friction coefficient for the general contact, which takes care of possibility of bellow contacting itself. This is a single part, but the bellow can in fact contact itself. So we're going to use general contact to take that into account. And there is also this reference also uses automatic stabilization, which I'm completely ignoring. I didn't do it. Now we will see that some of these dialog boxes are going to be useful later on, and we'll do that as we come along, particularly this one. Okay. All right. So I'm in generative shape design because I would like to create a surface later on, but these points have to be created, and the different ways of doing it. One way is to put the coordinates in an Excel file and read it. The other one to create them in a sketch, and the third one is create them in space. But I'm going to do that in a sketch. Okay, so let me go ahead here, and on the convenient plane, on that vertical plane, because eventually I want to rotate this thing, I'm going to sketch, and these points I'm going to create one by one, 11 of them. So here's a icon for point, and notice that I move this thing here so that it doesn't interfere with my mouse cursor. So let's start with the very bottom one. It's going to be 50, tab, minus 20, enter. Now, if it closes, let me double click on it so it keeps it open. Okay. So the next one is 50, tab 0, enter, 50, tab 20, enter, 50, tab 40, enter, 50, tab 60, enter, 50, tab 80, enter, and 50, tab, I believe 100, yep, 100, enter. Now the other ones are on the outside of the bellow, so it's going to be coordinate on 100, and the first one has a y coordinate of 10, enter, and then 100, tab 30, enter, 100, tab 50, enter, and 100, tab 70, enter. When you're done, just click on the point here so that that box goes away. And these are the points that I wanted to create. Now, the lines, I'm going to use a profile. And notice that when I do a profile, for example, when I go from here, and I just noticed that this is, let me undo this, escape, try it again, because I want to make sure that I pick these points, otherwise I have to come back and make sure that they all go through these points. So let's do profile here. So you go from this point to this point to this point, etc. Make sure you pick the point. Now notice that automatic constraints are created, parallel constraint. If you don't want it, you can hold the shift key down and those constraints are not automatically created. But it really doesn't matter me. It doesn't bother me. Later on, if necessary, I can go and hide them or delete them, etc. So this is going to be the almost done. This is my last point. When you're done, just hit escape, and these are created. These constraints, if you don't want them, as I said, you can go to the sketcher under constraints. These are created. You can hide them if you want. So from here all the way to there, shift all the way to there, you can hide them. Okay, good. Yeah, the next thing is to create fillets. Okay, so for fillets, there's the icon for the fillets. So I click on it, and let me start with the first point, this point right there. Now notice that at the very bottom left corner, you can actually input the fillet radius. So it's going to be 3, enter. Then I'm going to select this one. And you input 3, enter. Repeat it with these other ones. 3 millimeters, enter. Now if you want to do this thing repeatedly, maybe I should double click on it and then select this point, 3 millimeters, and then here 3 millimeters over there, 3 millimeters, 3 millimeters, almost done, 3, and this point also has 3 millimeter radius, fillet radius. Good, this is pretty much done. So we're done with fillets. Now when we exit, we can actually revolve this thing about the z-axis, global z-axis, to get the bellow that we want. So let's go ahead and select the surface under revolve right here, extrude revolve, and notice that I cannot select them. You can do this one by one. The faster way of doing this thing is join these, and then you can revolve at the same time. So if you go to the feature transform, I believe is there, join, and patiently pick these pieces, this and that and that. We're joining it. So these pieces are all picked, and say OK. They're all joined together. All right. Now we're going to revolve this thing. So it's going to go to on the surface, revolve. You can select the joint from the tree, and for the coordinate system, for the axis system, you put the cursor there, right click on the insert wireframe, you select the z-axis, and there we are. So this is the bellow. Oh, the rotation is 360 degrees, so 360. Okay, good. There we are. So the bellow has been created. Why don't we apply properties to it? So let's go to view, not view, sorry, tools, uh, create a material. I'll call it bellow polyethylene. Okay, so say okay. Right there, right click, apply. I'm going to close this and put it on my part. And we can input the properties in it now. So let's go ahead here. Right there. Double click on the structure. ABAQUS multiphysics, mechanical, elasticity, elastic, 100,000 megapascal, 100 with 3 zeros, another 3 zeros, and 0.38. I believe that was the Poisson ratio. And we say OK. Very good. Now, by the way, anything that you don't like, you can hide here. For example, notice that if I don't want the sketch, I can hide it. And of course, these points go away. Stuff like that. So I'll just leave it the way it is. The joint, for example, you don't want it, you can hide it. And of course, yeah. And if you want to change the rendering, for rendering, tools, not view, so view for rendering, you click on this. And if you want to, basically hidden line not showing, you go through these, yeah. So that's fine. Goes. All right. The next step is to go to the structure model creation, or you can go right there and just proceed. I'll go structure model creation. Okay. And of course, there's a standard model right there, standard model. It's going to be mesh size. I mentioned in the slides that this reference is actually using 2 millimeter. I'm using 4. Okay, so let me go ahead and make a 4 millimeter, and it is bilinear right there. And so we say okay. Right. The thickness I can specify here. The thickness of the uh, shell is 1.5, and we say update. Just going to mesh this. There we are. This mesh is considerably coarser than what this fellow is doing. All right, so we're done here. We want to check. If you want to check something, check the property. The thickness better be 1.5. 1.5. Okay, very good. Now, we're done here, so we're going to go to the I'm going to go to the structural model, structural scenario creation, or I can go to mechanical scenario creation. Here, if I go there, I have only licenses for a specific role. That is sufficient for what I'm going to do. Here, you have other licenses, such as license to the explicit version of the ABAQUS program, etc., or 3D Experience program. So you click on it. Yeah, one thing I actually forgot to do, let me cancel that for a second. That's okay. Let me go back because I want to create, just like this fellow is doing, I want to create a node set up there. Now, 3D Experience doesn't call it node set, okay? I have to do that in the group. So groups, I can do that right here I have to do it actually in the model, okay, while I'm in the model. So let me actually make a group on the top and a group at the bottom, and I'm going to do that by special space. Well, you make that spatial group because it's easier. For example, you can either make a window, etc., but you can make uh, a geometric group. Geometric group. You click on it, select that top edge. You see this? All of these are going to be the nodes on all of this top edge are going to be selected and put in a particular group. So I'm going to call it the top, and it's a node that I want. Okay, so we say okay, and then another one for down here. So another group, geometric group for this bottom one, and I'm going to say bottom, bottom, and say okay. Good. So we have created actually two groups here. You can see that. One is called top, the other one is called bottom. Now that we have done the group, so we're going to go to where I was about to go, general structural scenario creation. We're going to do structural, and from here you select the finite element mesh that was created. All right, so under the procedure, we select static, and in conformity with what the reference is doing, the initial time increment, I'm going to go 0.01. And then notice that the geometric nonlinear effect is on by default. Okay, what is this saying? 0.01. I'm sorry, this should be 0.01, not 0.1. Not 1. 0.01. Okay. Geometric effect is on, so we say okay. All right, and that is basically what this fellow has done. You can see that geometric nonlinear geometric is on, and initial is 0.01. Okay. Good. So, right. So the next thing for boundary conditions, for example, it's the clamped one, the clamped boundary condition, and I can select it from the group, the top, or I can go here and say, show me the groups, okay, and I can select it from here. The top is clamped, okay, and then we want to push this thing up, push this bottom group up by 25.4 millimeter, 1 inch. So we go here to the translation, and once again you can select it from here, the bottom, or you can go and say group and then select it. Okay, I'll select it from here, bottom, and the amount of translation is upward, which is 20. Is it 24? I think 24. Wait a minute. 1 inch is 20. 25.4. I'm losing my mind here. 25.4. 25.4. 25.4 or 0.4. Okay, in the direction Z. All right. So we say okay. Now, I need to create an interaction between or a interaction and then contact, self-contact later on between these things. So here's the way it's going to go. Under interaction, First, let's define the properties of contact. So we go here, contact property, expand this thing, specify tangential behavior, and I think the fellow is using, a reference is using a coefficient of 0.2, friction coefficient of 0.2. So here we put down 0.2. Nothing else is going to be changed here. And on the normal contact behavior, let's make sure that this is the default hard contact, etc. And I'm not going to do anything about that damping business. So this is fine. Now that we define the nature of the contact, which is contact property 1, we're going to do the general contact. Okay. So here, for contact property, first of all, for contact property, general contact property, we use contact property 1 that we created. And then there is a, let me take you to this slide there. And then there is, we already did this, there is something called contact property assignment right there. So let's go here, contact property assignment right there. And then create a contact assignment. Okay, so that, what you see here is actually this one, this slide, or this dialog box. So from the tree, so this is a self-contact, from the tree, or from this, the screen, or from the tree right there, we select the surface contact, surface quad mesh 1, okay, there. So basically what you have seen here is this diagram, this dialog box, okay? And we say, okay. See where is the okay? I'll be able to close this. Oh, okay, right there. And of course, it's the default stuff there. Oh, contact property 1, okay? I would have expected, because it's done here, that would be not be necessary, but it looks like it is. And we say okay. And we say okay. And hopefully everything that we want is done. And now we're going to go and first of all go to the simulation tab, do a model check, quick model check here. And I'm sure it's going to go through. And simulation check. Oh, one thing I want to do before I do simulation, I want to choose the type of element that our references serve. If you go using, so we go to structure analysis case 1, this branch expanded, double click on the global global element. Notice that actually it's not using reduced integration. I forgot to change this thing, so I'm going to go and do reduced integration. And if there are any, there are some triangular element, use the reduced integration. And we say, okay, I forgot to do that. It was not using reduced elements. Okay, so, but just to be in conformity with what this reference is using, the type of element was S4R element, okay? So we fix that. We don't have to do the model check anymore because there were no messages at the beginning. So we're going to do a simulation check. And finally, if there are no error messages here, we're going to simulate it. Oh, there was an error here. Let's check that. Licensing error, and that has nothing to do with the mistakes that I may have done. I just have to get out and let me save this thing. Close. Let me save this. I'm going to try to run it again, but if it still gives me that licensing error, basically I have to get out and get back into it. Somehow it's not giving me license. I'm doing this thing remotely on a server in Europe, so let's try to do it one more time. Let's see. I'm going to do the simulation check, see if it still gives me that license error. Yeah. Okay, so let's do this. Once this finishes, I'm going to close it. Things like this happen, but okay, so we already saved everything, and as a matter of fact, let me just rename this thing properties. I'll call it uh, something that I can find it easy in my license. Okay, save it and get out. Okay, so let me close this and close that, and I'm gonna close the entire 3D experience. So we're gonna go back in there. Let me start with let's go to the structural scenario creation. Okay, so it's telling me that do you want to restore that session? I'll say yes. Otherwise, otherwise I go and check my content and bring it up. So I'm going to say restore. Hopefully this time when I try to run it, it won't give me error messages. The only reason I changed the name to my license is that in the event that I have to search for it, at least I know uh, what name I should be using. We'll see. Okay, came up. And let's hope that this time it works. A model check, I'm not going to do that. It's okay, but why not? Okay, this is where I got the license error before. Okay, so let's see. I hope that we don't get this error related to licensing. Yeah, we didn't get it. It has happened to me before, so this is the way I handle that. There may be other ways, but that's how I did it. It is a good idea to do these checks because if there are any significant obvious errors, it's going to pop up and you're going to fix it. Here, solution check completed, and now comes the simulation. and say OK. I believe that this problem, the deflection is not big enough to cause a self-contact, but I use the same information that the reference used, so you may want to push it later to see if actually a contact is created. In fact, if we do have the time, we will push it further and see how things are going to go. This one is okay, so I'm going to say iterations, and it's going to be actually fairly fast. When I use a smaller size element, it took longer, obviously, so that's why I changed it to 4. And it could be that if I push it further up, the size of the element is not small enough that actually convergence will take place. So this is going very fast, as you can see, because there's no contact. But I will try maybe pushing it further up by another 10 millimeters. And if it doesn't converge and it stops, that's because probably the size of the element is not small enough. We're almost halfway through. Almost done. Okay, this is done. So let me close that. And of course, that is the initial step. So as you go further down, you can see that the stresses will change. Now, uh, I don't believe there are any contact here. It's kind of hard to see it from the figure, but let's actually try to push this thing further down. Further up, I mean. So we go to the structure model. We go to the under load, apply translation, and let's double it up. So let's make it 50. We'll see. Say okay? And in all likelihood, this will fail. So let's go ahead because the size of the element may not be big enough. So we don't have to do these checkings, okay? So I'm going to click on just simulate. Okay. And then let's check the iteration count. So what happens is in a case like that, uh, if it fails, it will store still at some stage if it fails, for example, maybe a thing is becoming in contact with each other, the previous stuff is going to be available, okay? So we'll see. So far, there is not much difference. It's going very fast. In all likelihood, there is no contact detected here yet. Uh, Obviously, up to 25 millimeters, there's not going to be an issue because we already ran it. So it's past that that may cause a problem. And I can see that the number of iterations actually is is increasing perhaps here. Let's see. You see, this is the halfway point, approximately 25 millimeter. It has moved by approximately 25 millimeter. Half of 50 is roughly 25, which should be okay because we ran it before and there were no issues. Now keep in mind that if the thickness of this shell was more than 1.5 millimeter, it could be that thing becomes in contact with itself much faster. I don't think there were any issues here, so let's close it. Yeah, so it doesn't show any contact. Oh, fair, fine, that's good. Now we were just trying to check the process and compare it with the way this reference is doing it, and things look good, and hope that you find this thing useful.